morning. I read some comments on last last feedback question. I think some of you suggesting to have a early midterm. Is that also a possible schedule, or for example, we set the midterm 31 October, right? But do you prefer like 1 week early, like 24, also okay or not? No. Okay. just asking. I will ask again later. I will have some like polling. You can choose. Okay. I mean, if you choose 24, it means that we only have today's class as a class before.
We have thermodynamics of material.
Oh, I see. Okay. So maybe that student didn't take the same class with you, maybe. Okay. So my plan for today's class is basically I will show you some of the last year midterm. But last year the midterm is a little bit different because we also include the next chapter. Okay. So let me just show you what kind of question we have. Okay, this is a question from last year. So first is classification of the differential equation. So we classify each equation with some specific method. You can think like how to solve this for number one. One equation can have more than one method. It can be 2, 3. Okay. Because sometimes you can have like a separable method. You can apply linear equation method. You can apply, or even the exact equation also you can apply. Maybe you can think for a while this one. And then there is a little bit tricks for some equation here, because it doesn't always work with dy dx. It can also work with dx over dy. Because I don't specify which one is which, so you can assume and you can rewrite the independent variable is not x but y. You can exchange x and y. How about the first one? What kind of method you can try to check? Separable.
Also linear.
Linear. Okay. I think separable will be a little bit difficult because of this. We need to exactly separate y and x because this is one component. If it is separable, maybe we need to change the equation, maybe y minus xy, maybe. I think that will be separable. But this one, I think not separable. But we can make this as a y minus x, and then dy, and then equal dx. If we make this dx dy equal y minus x, or if we write dy, dx dy plus x equal y. Now this is a linear, right? This is linear, but in x, okay? Linear in x. So we can say that we can solve this by taking a linear method in x variable. What about number b? It can be more than one. I think number b can have more than one. So I think for B, I think I can rewrite dy dx. Or let me write dy over 10 minus y and then equal 1 over x plus y dx. This is dx. Yeah, we can split, become this two, right? And this is separable, right? It is separable. So we can write this is separable. But we can check for other methods as well. It can be the exact equation, right? It can be exact equation. And they both have the same second partial derivatives, right? Second partial derivative. Exact. And also we can write in terms of dy dx equal 10 minus y over x plus 1. So we can write this dy dx equal y, or maybe plus y 1 over x plus 1 y, right? And then equal 10 over x plus 1. We can have a linear also, right? We can have linear. How about this number C? Can we make Bernoulli from here? So expectation is because we have y squared here. Okay. So we need to make sure that we have dy dx, and then we have some variable y. And on the other side, we need to have like y squared with multiply with some function. I think it will be a little bit difficult because we need to. So let's say we are going to start to. So if we take y over y, this is 1 minus xy, and this is equal dy dx. Then we remove the square, so it doesn't have Bernoulli, right? And we still has a complication within this. How about we reciprocate this and write as a dx dy. So we take dx over dy equal y minus xy squared, and then divide by y. which give you the 1 minus xy. And then we can rewrite this as dx dy plus xy equal 1, which is linear. Linear but in x. Okay. So the linear doesn't always dy over dx. Okay? It can be in any variable. You can design your structure, but for example, using the x and not y. And then if you check the exact, it's not exact, right? Okay, how about the last one? Last one. dy dx. Again, the problem is the x minus y, right? If you want to separate, it doesn't separate completely because this component x minus y. So, any idea for number D? Oh, number B, it is exact because we can derive this. We can derive this is equal the same. And remember, to make sure the exact equation exists, we need to write in this formula. Okay, so exact equation, let me write here. So exact is when we have this m dx plus n dy. So you see that we have m dx plus n dy. So we need to have into this equation, which means that we need to move out this part, go to the left. Okay, what number D? Number D? Any idea what will be? Is it linear, separable? I think it's not separable, but is it linear? Is it linear? And remember, we have all the plot twist. Linear but in x. Linear in x. But perhaps we can also do the same thing. So we make it dx over dy. Let's reciprocate that. So let's make dx over dy. And this will be x squared minus xy, which we can rewrite this as dx dy plus xy equal x squared, which is Bernoulli. Okay. Bernoulli but in x. Okay, maybe next question. Number 2, I think that there are some parts that is the next chapter, which is, so no need to worry about number E and number D. Let D and E is for the high order differential equation. I think ABC is okay, right? Okay. Number A is true. And number A is true because you can see from the forms. The forms and the, remember the autonomous differential equation means we only have an equation for y. So it will be true because of the autonomous behavior. It's only on y, which we can separate easily. Okay. Number 2, differential equation y squared plus dy dx equal 1 second order equation. Of course, it's not second order, right? Because the squared means it is the, or we can just focus on the differential, which is the dy dx, which is only the first order. So this is the first order. So this false. And then you have 2xy dy dx plus y squared equal to x squared. Maybe we can set up the equation and divide by 2xy for all components. And you will see that it can be solved through Bernoulli equation. But the question is that only solution through the Bernoulli method? And you will see later we can have another method as well. So it's false.
We can go for linear.
Yeah. I think we can solve through some other method as well. So we answer number C false because not only Bernoulli, we can have other method as well. Number D and E, we can skip that. Okay.
So,
Yeah.
second order is going to second derivative, yeah?
Yes, correct. Okay, so number 2, okay. Number 3, okay, number 3. So there.
Genetic this picture.
Oh, okay. Okay. So number 3. Okay, I'm giving you maybe some time to check. Okay. Number 3 and 4. Okay, number 3 and 4. Because number 5 and the rest is all the higher order. So only 3 and 4. And this will be, I think, a typical 4 exam. So perhaps your question will be a little similar like this. But of course, we will not the same. At least the difficulty will be similar. And your midterm will be calculator alone, and you can prepare your A4 notes. Both sides, A4 both sides. I hope you can prepare very well. And I think my suggestion is when you prepare the A4 notes, instead just copy your notes. Sometimes when you write the notes, try to understand what you're writing. And then maybe if you need some example, put some example so that you can have more understanding. So when you have the exam, like you have the question and you know where to find in your notes. It doesn't, like usually you write the notes like crazy, everything you put in, but and then you have a question and you are confused which one is in my notes, and then the time will waste it. So I think you need to have a good management in your notes. I think you can first you can see some method that can be done. For example, for number A, can it be separable? I think it will be very difficult because we have this y squared plus 2x, which is not easy to separate. For the top one, you can factorize y. Right? You can factorize y, and it can be somehow a little bit separated. But the denominator is difficult to separate, so I don't think it's separable. I don't think it's separable. And then we can also try the linear. Linear also, you see that we have some complication here. So I think if you have this kind of questions, like a fraction like this, but you can have easily you can move all these components, and each one can get the x or dy, right? Which means you can have, or you can check the exact equation. So first you can check the exactness. If it is exact, then you can use the exact equation method. Okay. So we can have 3y squared plus 2x. This will be the x. And then I will move all the components on the right side to the left side. So this will be plus 4y squared plus 6y. And then remember that this is m, this is n. How to check the exactness is basically based on the partial derivatives, which stated that the partial xy is equal partial yx. Okay, so if this is our partial x, so we need to derive with y. For n, we derive with x. To make this exact, we need to make sure that they are the same. If they are the same form. So my, let's write like that. This will be, so we derive the m with respect to y. Or maybe let me write, maybe it's easier to understand like this maybe. 3y squared plus 2x. So in the partial, if we derive with respect to y, the other variable we treat as a constant. Okay, remember that. So this will be 6y. And this one we derive with respect to x, which give you also 6y, which means that this is exact. Then we can proceed and try to find the solution. So we can proceed and we can rewrite m as a partial, or let me write partial. Maybe to make difference, the partial, the d is supposed to be a little bit curvy, so let me rewrite the d. The Leibniz notations, basically the same thing, but to make sure that we know that this is the partial. So we write the partial. Let me write f as our function that we need to find. So partial, this is equal to m. So let's integrate with respect to y. So we take dy over there. And then our proposed structure will be 3 why this is dy, sorry, dx, why I'm writing dy. So 3xy squared plus 2 by 2 is x squared, become x squared, and then the constant, we imagine that there will be some function of y. And then the n is partial with respect to y. This is equal to 4y squared or maybe let me write, this is plus 4y squared plus 6xy. Okay, if we derive the f, we can derive the f. So we derive this will be with respect to y, this will be 6xy plus g prime y, right? And then it needs to be the same with, so this is n, okay, this is m. So this structure here need to be the same with this. So we see that we have 6xy the same, and then we have the g prime y that will equal to 4y squared. So we write that g prime y, our proposal is 4y squared. So if we take integrations, this will be 4 over 3y cubed. So the proposal for our f is actually 3xy squared plus x squared plus 4 over 3y cubed, and then just equaling to c. Or if you would like to write minus c is also okay. Or if you would like just to write the equation also only, it's also fine. The fxy is this. That's also okay. I think I can also prepare maybe some practices, maybe 6 to 8 questions randomly from the textbook. I will pick some of them, and you can have some exercise within this week and next week. So if midterm is 31, so we still have like next week, but next week we need to move to another chapter, okay? At least the introduction and introduction. So last year, the midterm is actually first order then higher order. It's too much content. I check and evaluate maybe too much content. So I decide this year, I have only first order, so only introduction and the first order, but including the Euler's method, Last year, I skipped some like specific method, like Euler's method. I'm skipping all the numericals. Also, actually in your textbook, you have the linear models that I also skip. I will focus only the method in differentials. Because I think other type of problem in your textbook, including the linear models and then some phenomenon that can be solved through differentials, like in physics or in chemistry. But I think I will skip that part. Okay, how about number B? Can you solve this? Let me give you some couple minutes to try. It requires some knowledge on integration, some integration techniques. But you can try. Any question from the number 8 for the exact equation? Any question about that? Do you think you can do it in the exam? Okay. So exact equation, you can start from m or you can start from n. same. So if you start from n, then when you integrate, you will have some function of x. And then you differentiate, and then you will equal it to the other one. Okay. So basically, at the end, we need to find this g prime of y, which you can see from n. Okay, number B. Anyone try number B?
Actually, forced to.
Yeah, I think it's not okay. You can just take this out. Yeah. Yeah, cosine squared. Okay, I think some students already got correct, so we can separate the equation, become 1 over secant squared x dx, and then equal y squared plus 1 dy. And then you can, I think you can just integrate. And 1 over secant squared is cosine squared, right? So you can just use cosine squared. And how about the right side? We have y over y squared plus 1. We can, I think, use substitute, right? You can use substitute. So we can take, let's say this is u is y squared plus 1. Du is 2y dy. So we'll have a half, right? A half of the 1 over u, right? Du, and 1 over u becomes ln u. So we have on the right side, this will be half, and then ln of the y squared plus 1. You can add plus c if you want on the right side. And then cosine squared, remember every cosine squared or sine squared, it's better to just take to the double angle formula. So the cosine 2x is equal to cosine squared x minus 1. You can just change to this. Okay? So the cosine squared x become half cosine 2x plus half. And then you will see that this will be sine. Oh, I am using green color. Let me change to blue. So this will be sine 2x over 4 plus half x, and then equal with that. I think you can keep this way, and you say that this is implicit solutions. Okay. You don't need to write in y equal x. You can just skip this, and then you can write, okay, this is implicit solution. It's still okay. Or if you want to simplify, maybe remove the half and 1 over 4. You multiply with 4, it's also okay. Okay, last one. Last one is, I think, simple, right? So you have like a bunch of equation here, and we have some constant h, which we want to find, like what is the h value if we want to make sure that this differential equation is exact. Which means we define this will be n, this will be n, right? So we partially differentiate both that need to be equal. Okay. So we need to set up the partial y of m need to be equal with partial with x with n. Okay, so we have y cubed, we differentiate, becomes 3y squared, and then plus, this will be 4hxy cubed, right? And then 2x becomes 0. And then it needs to be equal with the n. So n, we partially derive with x. So 3y squared, okay, and then we have 40, so we have plus 40x y cubed, which all the components, they are all the same, xy cubed, and this is 40, this is 4h, so h will be 10. Okay, h will be equal to 10. Okay. Okay, any questions? Any questions? So I think last year I didn't prepare question for the substitution or Bernoulli. So I may prepare that question. So I hope you can prepare as well. So next week we have 2-hour class. I will prepare 2-hour class for the next chapter. And 1-hour class maybe review and your midterm preparation. So I will have more practice exercise again. Oh, for the Saturday? Yeah. I'm not sure. I will report. I will report. Oh, Saturday we have a class. Yeah, Saturday we have. Yeah, this Saturday. 8. At third floor. 301. 3012. Okay. Or 301. I will write in. So third floor. Okay, if there is no question, we can continue on Saturday. Okay.